Newton's first law states that an object in motion tends to stay in motion, while an object at rest tends to stay at rest, unless an outside force is applied. This is also known as the law of inertia. Inertia is the tendency of an object to resist any changes in movement. For example, as the ball rolls down the hill, the outside force that is applied to put it at rest is friction, which is the grass. As the other ball is at rest, the outside force that is applied, which is Peyton's foot, causes it to go in motion.
These are examples of Newton's first law because the balls are either at rest or in motion, but then an outside force caused them to change.
Another example of Newton's first law is when a person is driving in the car and they slam on the brakes, it causes their body to jerk forward in the car.
This is also another example because the body was at rest, but the sudden change of speed of the car caused the body to move forward. Newton's second law is a net force acting upon an object causes the object to accelerate in the direction of that force. For example, Dan is going to kick the ball and his foot is going to move forward, causing the ball to move forward. The second part of Newton's law is that if the force stays the same when it is applied to two objects and the mass of one of the basketballs is greater, then the acceleration of the ball with the greater mass will decrease. So Dan is going to kick both of the basketballs, but the bigger one is going to not go as far because it has a greater mass. If you want to find the force and you know the mass times the mass and the acceleration, you would do force equals mass times acceleration. For example, if you know the mass of the basketball is 5.0 kilograms and you know the speed is 10 meters per second squared, you would do 5 times 10 and you would get 50 newtons as the force. And if you were to want to find the acceleration, you would do force divided by mass, and if you wanted to find the mass, you would do force divided by acceleration. Newton's third law is that for every action, there is an equal and opposite reaction. So as Dan is bouncing on the trampoline, his action is going up and starting to come down, but his reaction is when the trampoline comes down with him, and then it shoots him back up.
Another example of Newton's third law is as I am bouncing on the trampoline and there's water on the trampoline from the rainfall, the water splashes up as I come down on the trampoline.
A third example is when you blow up a balloon. The balloon, with the air filled, the air will go that way, but it will shoot the balloon the other way. Or it'll work the other way. To sum up, Newton's third law was for every action there is an equal and opposite reaction. All three of these show that because there is an action like Dan jumping on the trampoline or the air coming out the other side of the balloon, and the opposite reaction is when the trampoline shoots Dan back up or the balloon shoots the other way.